Hello, welcome to Prajim Technologies. I'm Venkat. This is part 55, late binding using reflection. If you haven't watched part 53, reflection basics, I would strongly encourage you to do so before continuing with this session. Now, in this session, we'll understand what early binding and late binding mean and the difference between the two approaches. So let's start with an example as usual. Okay, so if you look at this code here, I have got a customer class, and within this customer class we have a get full name method, and the return type of that method is obviously string, and it takes in two parameters, first name and last name. So what this method does is concatenates them together and return the full name of that customer. So now let's say if I want to use this customer class, the way we do it is, okay, customer C1 is equal to new customer. So we are creating the instance of that customer class, and then if I have to invoke the method get full name, we say c1.getFullName, passing in the first and last name. Let's say the first name is Prajim and the last name is Tech. Okay, and we know that this method returns a string, so we use a string variable to hold the returned value. So let's say string full name is equal to that, and what we do in order to print it, we use the console.writeLine method. Full name is equal to, and then we pass in the full name. So if you look at this, it's pretty simple, and we have been doing this kind of coding all this while. So if we run this now, as you might expect, it will print the full name. Okay, so what is this? This is nothing but early binding. Okay, at compile time, we have the information about this customer class. We know about that class, so we are creating that instance, instance of that class. Now let us say when I am invoking this method, by mistake, instead of get full name, if I just put an s there, a typo, and if I you look at this one, I already got a red squiggly indicating that customer does not contain a definition for get full names. Okay, so if you make any spelling mistakes, those will be flagged at compile time itself. Not only that, instead of that this get full name method, if you look at that, when I highlight mouse over this method, the IntelliSense clearly shows me this method is going to return a string data type, and it's going to expect two string parameters. Now instead of a string parameter here, if I pass in something like an integer 10, for example, even that will be flagged immediately at compile time as an error. Okay, so the possibility in early binding, all the errors, any spelling mistakes or type mismatches in terms of passing in parameters or the return values, all of these are detected at compile time itself. So the probability of runtime exceptions because of type mismatches and spelling mistakes is very less in early binding. In fact, it's not possible. If you misspell that, your program will not even compile, so forget about running it. Okay, so most of the errors can be detected at compile time itself in early binding. Okay, but when we look at late binding, that's when you'll understand the problems of late binding, and we will see what late binding is in just a while. But for the time being, what you need to understand that is that when you have the knowledge of the class for which you are creating an instance at compile time, then you usually use early binding, and 99.99% of the scenario in reality we use early binding, and it's very rare that we use late binding. First of all, let's look at an example of using late binding, and then we will discuss the difference between early binding and late binding. Okay, so this is pretty simple. This is early binding. Let's comment and keep this code. Okay, now how we do late binding? First of all, we will do late binding only when we don't have the knowledge of the class for which we are creating an instance at compile time. Let's say that this customer class itself is not there at compile time. So if I comment that, obviously it's as good as saying we don't have the customer class at compile time. So let's keep it commented for the time being. Okay, but what I want to do basically is I want to invoke this class in spite of not being available at compile time. At runtime, when I run this program, I should be able to create an instance of this class, and I want to be in a position to invoke this method. But now if you try to create an instance of a class about which you don't have information at the compile time. Look at this. I have a red squiggly indicating that the type or namespace name customer could not be found. Are you missing a using directive or an assembly reference? And that makes sense because there's no customer class here. So what are you trying to do? So in situations like this where you don't have information of the type which you want to instantiate, is not available at compile time, then you go for late binding. If it's available, we go for early binding. So let's see the code for late binding. Now, first of all, you will have to load the assembly which contains your class. Now, obviously, this program, this project, when I compile that, it will be compiled into this assembly, introduction to C#. Okay, so ultimately we'll have our class within the same project. So we need to load this assembly, and to load the assembly we can use the assembly class. And by the way, if you want to do any reflection, all the reflection related classes are present in system.reflection namespace. So let's go ahead and import that. And then within this we have an assembly class. So assembly, let's call this executing assembly because our class is also going to be present in the same assembly, and this is the executing assembly in the sense when we run this program, the code within this assembly gets executed. So executing assembly is equal to, now what I want to do is I want to load the assembly, and to do that we have this method assembly dot get executing assembly. There's a method called get executing assembly, and then what this method basically does is it looks at the program. Okay, the program is currently executing, and this is the assembly. When this main method gets executed, where is this main method present? It's present within this project. So obviously within this assembly this main method is present, and our customer class is also going to reside in the same project. So we are loading the current executing assembly. Okay, so once I have the executing assembly, within this assembly, we have two types, in the sense two classes. What are they? Main class and customer class. But what we want to do here, we want to load the customer class and instantiate that dynamically at runtime. So we need to get the type information about that customer class. And to do that, the way we do it is we use the executing assembly dot get type. So there is a method. Now if you say get types, it will return you the type array, but we want the type, just one type, which is nothing but the customer class. So get type, and then if you look at that, it is expecting the name of the type. So let's pass in the name of the type. Now if customer class is going to reside in this assembly, then the fully qualified name of this class is prajim.customer. So we need to pass in the fully qualified name. So prajim.customer. If you don't pass in the fully qualified name, then you risk a null reference exception. We'll look at that just in a bit. Okay, so if you look at this get type, what is this method returning back? This method is returning a type back, and we have seen this in part 53. So type, and let's say, what is this type? Customer type. We know that we will get a customer type back. Now look at this. I don't have this customer class, but still if I compile this, it will happily build without any problem. Because look at this, we don't need to have that customer at compile time. At runtime, it checks this assembly. Okay, if this type is there, then it loads that into this. Otherwise, it will be null. Okay, so all right. So the second step is to get the type. Now, not only that, once we get the type, we need to get the method, okay, which we want to execute. But before that, we need to create an instance of this particular class. Look at this. When I say get type, I get the type of this class, which is nothing but the customer class. So once I have the type, I need to instantiate that. And to do that, the way we do it is we use activator. There's a class called activator class within the system namespace activator dot, there is a method called createinstance, and this method, okay, we want to create an instance of this customer type. So we pass in the customer type, and this method will create an instance for us. Look at that, that returns an object back. because you don't know the type at the time being, so you have to use the object type. So we will call this object customer instance is equal to create instance. So we got the customer instance, we have the customer type, we have the customer instance. The next thing to do is to get the method information that we want to execute. We know that the customer class is going to contain get full name method, so we want to get the information about that method. And to do that, you can use the customer, because the method is present in the customer class, okay, customer type. So on that type you can say customer type, not instance. So customer type dot get method. Look at that. What is this going to return? This is going to return a method info object. And remember, we have spoken about this in part 53. So if you haven't watched that video, I would strongly encourage you to do so before continuing with the session. All right. So this get method, okay, method is actually expecting the name of the method that you want the information about, which in our case is get full name. So we need to pass that in here. So get full name, that's the name of the method. You just need to pass in the name of the method. So get full name. So what is this going to return? This is going to return an object of type method info. So we need a reference variable to hold that. So method info, and let's call this as, just to give it a meaningful name, get full name method. Alright, so we have this method now. So we have got the instance of the object, we have the method itself that we want to invoke, but there is another thing that we need to do before we actually invoke this method. What is that? This method actually expects two parameters, first name and last name. So we need to create those parameters as well. And if you look at the parameter types, they are string types. Okay, so let's create a string array to hold both of these parameters. And to do that, let's create a string array and let's call that as parameters is equal to new string array. And since the size is 2, I mean we have two parameters, let's make the size as 2, and parameters of 0. Okay, that's the first name parameter. So you can pass in your first name there. Maybe the first name I want it as Prajim, and similarly we want to pass in the second parameter, and maybe we'll call this technologies. Alright, so we have the parameters, we have the method that we want to invoke, and we have an instance. Why we need an instance? Because this method is an instance method and not a static method. If it's a static method, we might not require the instance, we might just require the type. Okay, but since this is an instance method, we require the instance as well. That's why we created the instance of this customer type using create instance method. All right, so now last step is to invoke the method, and this is what is interesting. Now usually in early binding, to invoke the method, what we will do, we will say object dot the instance method. But here you cannot say customer instance dot get full name. Why? Because this is of type object. This is not your customer class. Your customer class don't even exist at this time now, because at compile time we don't have any information about it whatsoever. Alright, so there should be a way to do that, and the way to do that is the method that we want to invoke is this get full name method. So this is the method, and then on this method there is a method which we can call the invoke. So I want to invoke this method. Now if you want to invoke that method, since this is an instance method, it requires an object using which it can actually invoke this method. So where is that object? You have to pass the 10, and remember we have created an instance of our class, so we pass that object in. And the next thing, look at this guys, I mean it's pretty simple to understand. To execute get full name method, it requires two things: one, the instance of the class, and two, the parameters that it needs. Okay, so those two things we have to pass in to invoke this method. So we want to invoke this method, but it requires two pieces of information. One is the customer instance, I mean the object itself, and the other one is the list of parameters that it requires, which are nothing but these. So pass in the parameters, and And see, your IntelliSense tells you that. Okay, look at that. The first one is the object that we have to pass in, and the next one is the parameters array, object array. Now it's interesting to notice here, it is expecting an object array and not a string array, and that makes sense because you never know what are the different types for other methods going to be. Okay, and from inheritance session we know that every type directly or indirectly inherits from the system.object type. So now this will be casted to the parent type. All right, so that's why since string directly or indirectly inherits from the system.object type, you can pass in a string array instead of an object array. Okay, all right, and if you look at the invoke method's return type, look at this again, it's object. But in our case, what is the return type of get full name? It's a string. Okay, but again, string directly or indirectly inherits from system.object, so it's okay. So what you can do, so when this method gets called, what are you expecting back? You are expecting a full name back. So create a variable, maybe string full name. So this variable is going to receive whatever this method is going to return back. But if you look at this method returns an object, and you're trying to convert that to a string type, which is not possible, okay, implicitly. So you need to do an explicit cast. So string. Okay, so we have our full name now. All that is left out is to print that full name. Console.writeLine full name is equal to full name. Look at this, the amount of code is like 4 to 5 lines of code, but it's pretty simple. I mean, if you logically understand that, go from the reverse. If I have to invoke a method dynamically, whether you want to invoke a method using early binding or late binding, all you need is the instance to invoke it and the parameters. Okay, I don't care how you get them, but I need both of them to execute that method. So if I have to get the instance of the customer class, what we need to do, we need to first load the assembly which has got that class. From that assembly we need to get the type of the customer class, and then we need to create an instance of that customer class. So basically these 3 steps is to create an instance of a customer class, and then this step is to get the method which we want to execute, and this step is to prepare the parameters that this method expects, and finally invoke the method passing in the customer instance and the parameters list, and then typecast the return type to what you are expecting. In our case it's string type, and then finally print it out. That's it. Okay, it's a little bit of code, but definitely late binding code is a little complex than early binding. So obviously now if we run this, okay, there is an unhandled exception which is bad. So let's see where we are getting this unhandled exception. It's saying value cannot be null, and it says the error is at line number 13. Let's see and fix the issue. So line 13, so control G 1 3. Let's see where is that. So for some reason here we are getting an error, and obviously it makes sense because we don't have this class yet. So what you need to do is uncomment this, because at runtime this needs to be available, right? Look at this. So you are expecting some assembly and class to be present at runtime. If they don't, obviously you'll get a null reference exception. So now when we run this, you should say presume technology is the full name. Okay, but on the other hand, look at this, guys. If you misspell the name of the method, okay, and if you build this, it will build without any problems. So build succeeded. But when you run it at runtime, you will get a null reference exception. Why? Because get full names, when it tries to get that method, it will be null, and you're trying to call an invoke method on a null object. So obviously you will get a null reference exception. So that's why these names, you shouldn't be misspelling or passing in the wrong types. Not only names, even if you pass in a wrong type, instead of a string parameter, if I pass in an integer parameter, the code will compile, but in runtime when you try to pass those in, we will have problems, runtime errors. Okay, so that's about late binding. But keep in mind, guys, late binding, it has got first of all, it's complicated, number one, and number two, it has got performance issues as well because it has to load an external assembly, resolve the type, create an instance of that at runtime. A lot of things has to happen, and obviously late binding is much slower than early binding. So 99% of the time prefer early binding over late binding because it has got much performance. And not only that, in early binding we can flag out any compile time errors like spelling mismatches or type mismatches, but in late binding we'll not come to know about them until you actually run your application. So if you look at the code for early binding on the slide, you can see that it's just 3 lines and it's pretty simple and straightforward. But late binding has got significant amount of work to be done. And if you look at the differences between early binding and late binding, early binding can flag errors at compile time. With late binding, there is a risk of runtime exceptions. Early binding is much better for performance and should always be preferred over late binding. Use late binding only when working with objects that are not available at compile time. Alright, on this slide you can find resources for ASP.NET and C# interview questions. That's it for today. Thank you for listening. Have a great day.